Hi everyone. Today I am going to tell you what you mean by beam of composite section. You can see the beam of composite section I have written on the board. What is beam of composite section? That is nothing but a when beams are made up of more than one material. So what I mean when beams are made up of more than one material is called composite beam. For example, we can give example for composite beams are bimetallic beams, sandwich beams, flitched beams, and reinforced concrete beams. So, as already I have shown the flitched beam, symmetrical and unsymmetrical section of the beam, symmetrical and symmetrical section. So, such composite beams can be analyzed. When it is analyzed, it can be analyzed by the same bending theory. It is analyzed by the same bending theory because the assumption that cross section that are plane before the bending remains the plane after the bending also. There is two section. One is symmetrical section and another will be unsymmetrical section. If you take the symmetrical section, that will be the flitched beam. So we can take the example of two timber pieces. I have shown the two timber pieces in the diagram. Two timbers strengthened by a steep strip. You can see the strengthened by a steep strip sandwiched between them. So you can see these are sandwiched between them. So such a beam is commonly known as a flitched beam. So we can take a total D. This I have taken as a total D. If we take a total D as a depth of a timber, and if I take the total D as the depth of the timber and small b the depth of the steep strip, and small b inside this will be the small d. I didn't write it, but it will be the small d. As I say, it will be the depth of the steel strip. Similarly, let total be the total width of the timber section. So the total b, small b with the width of the steel strips, you can say. So from statistics they are given m is equal to m1 and m2. Using this equation I am going to calculate, and m is equal to, you can say m is equal to E2 by E1. Where is the modular ratio? That will be m. Small l will be the m will be small m will be the modular ratio, you can say. So finally the equation is given by m1 by m2. For a symmetrical section it is given by the m1 and by m2 is equal to E2 by E1. E2 by I1 divided by E2 by I2. So similarly for unsymmetrical section, I have taken the example for unsymmetrical section consisting of a strip. You can say this is a strip of which b width and d depth, b width and d depth I have taken of material 1 and strip of width b and depth d2 and depth d2 of material 2. I am considered as first material and second material. I was considered for depth d1 as first material and depth d2 as second material. The first step we will be finding the position of the new axis. For first step we are going to find the position of the new axis of the bending. So this one done by the equivalent section. So this, how is this is done? We have to draw the new axis. To find the new axis of the bending, we have to draw the equivalent section of the original section. So as you know, I have done the equivalent section here. By using this equivalent section, you can say already you know the moment m2 is equal to f2 into z2. If m1 dash and z1 dash are the moment of resistance and section modulus of equivalent section of plate 2, we have m1 dash is equal to f1 z1 dash. I am not written, but I am going to just inform you. So if you say m1 dash as equal to the m2, we have the equation like f2 z2. We have the equation here. We have the equation f2 is equal to f2 z2 is equal to f1 z1 dash. Okay, so after solving this equation we are going to get b dash is equal to m into b, where z1 dash and z2 dash are the proportional to b. So today I told you what is mean by composite section, and the examples of composite section for beams are already told you: bimetallic beams, sandwich beams, flitched beams, reinforced concrete beams. I have taken the symmetrical and unsymmetrical section. For symmetrical section I have given the example of flitched beams, and modular ratio m is equal to, already told you, E2 by E1. Modular ratio E2 by E1 I already told you. But whereas in the unsymmetrical section we have taken the original section as and done it a part 1 and 2. We are divided by one material as D1 and two material as D2, and the equal for calculating the calculate the new axis of bending, I have taken this original section to make this original section into equivalent section. And I obtained the equation b dash is equal to mb. You can see in the even in the equivalent section I written b dash is equal to m into b. This will be the way z1 dash and z2 dash are proportional to b, we can say. Thank you for watching.